All right, here we go. Today we are talking first about review of yesterday. Shh, quiet please. We had these triangles, and we were saying, would you please draw for me where 5/3 pi is, for instance. And then you had to draw a reference triangle, etc. All right, so I'm going to just do a quick little verbal response, and I hope you'll be able to answer these quickly and easily. How many degrees, if this is 0 degrees, how many degrees is supposed to be right here? 90 degrees. How many's right here? 180. How many's right here? 270. These should flow like water from a spring. Should be very easy for you. Okay, how about if I change it to 45? So would you know where those were? This one's 45. Then what's this one? 90. What's this one? That's not quite as easy because you got to take 90 plus 45 and you'd get 135. Okay, anytime you have those 35 things, you have to try to figure out what they're made of. Like if somebody says 135, you're not going to just naturally know, oh yeah, 135 is over here. But you got to say, okay, is 135 made up of a bunch of like 30-degree angles? That doesn't make sense. 30 isn't going to go into that nicely, right? But is it made up of a bunch of 45-degree angles? Yes. And so therefore you can say, oh yeah, must be three 45-degree angles in that one. All right. So let's do some of the ones that are a little harder. What if I start with zeros here, and this is pi over 2. What's this guy? Pi. What's this guy? 3 pi over 2. That's one of the hardest ones for people to remember. Memorize it. Get it straight, because it'll come out over and over again. Okay. Now, what if I had an angle that I wanted you to make me a reference triangle? Everybody try this one. It's just like yesterday's problems. Make me a reference triangle for 2 pi over 3. I'd start with a new circle and figure out what should I count by to get to 2 pi over 3. And once you find that thing to count by, you'll be able to find your angle, and then you should make a triangle, and then you should label the reference angle. 2 pi over 3. I like to say that as 2/3 pi. Because if you know where pi is, then you just got to figure out where 2/3 of the way there is. To me, this is powerful. To be able to divide, call that 2/3 pi. I think it's going to make you way better at memorizing where these things are. Because I know you all know where pi is. Boom. So where's 2/3 of pi? Well, it's 2/3 of the way there. So it's something like that. Now, exactly where that is? Well, it's not 3/4, which 3/4 would be exactly right there. It's a little less than 3/4, so I'm going to say it's about there. How many of you agreed with me? Raise your hand if you did. Okay, good. So that's 2/3 pi right there. And then the reference triangle, you always drop to the x-axis. You never go over like this to the y. Won't work. And then this triangle is my reference triangle. And inside there, all those numbers are nice. This is a 90. And also known as a pi over 2 if you're doing it in radians. And if this was 2/3 of the way there, then how much is left for this angle right there? 1/3 pi. And yes, that is 60 degrees if you are thinking in degrees. It'd be best if, just like they say when you're really good at a language, you start dreaming in that language. That's what they say. If you really understand Spanish really well, you actually start dreaming in Spanish. Not many people get that fluent in a language. I know there's some people in here that might be, but I don't know. But I can tell you in math, we're used to degrees. I agree. When I started teaching this, I always went back to degrees because I was comfortable with it. But as you get better at trig, it's actually best to start thinking in radians. So it's best if you start thinking in terms of where is pi? Got to know it's right here. And where it is 2/3 of a pi then. And then therefore this is 1/3 of a pi. And that's my reference angle. It looks like a half. Let me fix it. Okay, yes?
Can you tell us about yesterday you put our calculator in degree mode?
Yes, I did tell you to put it in degree mode. But when we're calculating angles with your calculator, we're going to do it mostly in degrees. Today we're actually talking about changing between degrees and radians. But when you're looking at these pictures, I think most of you are going to be fine when we do degrees. Because you kind of know what those are like. But the hard part that I want you to practice is getting good at the radians. All right. So that is a reference triangle with a reference angle. And now let's get into what happens if we want to change back and forth. And this is the new stuff for today. If you have radians and you want degrees, or you have degrees and you want radians. Now, could you draw the picture for it and do it that way? Some people actually like to do it that way. Or if I say, what is 2/3 of a pi in terms of degrees? So here's my question. Convert that to degrees. That would be a simple R2 question that you could see on a test. Well, there's two ways. One, you draw a picture of it, like we just did. And say, where's 2/3 of a pi? Well, if it's 3/3 of a pi is here, and 2/3 of a pi must be like right there, can you change that to degrees then in your head? Can anybody do that? Feel like, is that natural to you? Maybe for some of you. 120, does that make sense? All right, if that did not come naturally for you, which it didn't for a lot of you, I can tell, then I have a way that's going to save you on these. You just take this, 2/3 of a pi, and you are going to convert it over. Just like if you wanted to convert feet into inches, you'd multiply by something or divide by something. So let's just do a quick conversion of something simple we know. Let's say you had 36 inches. How would I change that into feet? I would multiply by inches on the bottom so that the inches would cancel, and then how many inches per what? What should I put in there? 12 inches per what? 1 foot. And if you multiply this, these would cancel, right? And then that's a good way to convert to feet. Do you get what I just did there? I multiplied by a fact. And the fact was that there's 1 foot and 12 inches go together. If I'd have put that upside down, do you get that the inches wouldn't have canceled? All right, so can anybody extend that analogy to what should I multiply by here? Yes? You got it, because I want the pi's to cancel. Perfect. Oh, you were close, but no, okay. But a pi is not a radian. What does pi go with on the big circle? Remember pi's over here? 180. You were really on the right track, you just didn't know how to finish, but it was a good start. Okay, so bottom line is you multiply by 180 over pi, or if that pi wasn't canceling because the problem was the other way, you'd multiply by pi over 180. It's just a matter of one or the other. You multiply by 180 over pi or pi over 180, because this is a fact, just like 1 foot is 12 inches. 180 degrees is like pi. They go together, it's like a fact. All right, so if I had a number like 270 degrees, and I just am not thinking in radians yet, and I have to convert this over, you multiply by, well, here's two choices. Either 180 over pi. Do you see how that would not work real nice? Because the degrees would not cancel. Do you see that? So then 180 over pi is not a good idea, so what do I multiply by instead? Pi over 180, because now you see the degrees will cancel. All right, try that one. Now you actually have to do the math, and there's no calculators allowed on this part of the test. What? 270 divided by 180? That's awful. Well, how about this? Cancel the degrees. How about canceling a 0? How about saying 27 is really 9 times 3? We agree everything I've done is okay to do? And then how about the 18? What's that really? 6 times 3, or 9 times 2, that's true. Okay. Now can anything cancel? The 3's can cancel, and now I can cancel the 9 and the 6, except I could rewrite the 9 as 3 times 3. And then I could rewrite the 6 as what? 3 times 2, and now I can cancel. Another 3. Oops, I missed. And the 3, I'll cancel the 3. There we go. So what's left? 3 pi over 2. So what did you just do? We just changed 270 degrees into 3 pi over 2. Now that one, you might have been able to go, here's where 270 is. Some of you wouldn't have known that, so that we would have failed right there. But some of you would have known that. And then some of you would have known, wait a minute, that's the spot where 3 pi over 2 is. And yeah, 3 pi over 2 is the right answer. So if you can do it intuitively like that, awesome. If you are going to multiply by a fraction, you're like most people, and that's okay. Your safety in numbers. It's always the zebra that's sick that gets eaten by the wolverines. All right. Or the test. Okay. So let's try one more conversion that I think you should be able to handle. No big deal. 5 pi over 3. How many degrees is that? Well, multiply by something. Do it on paper right now. You and your pencil moving. No calcs. So it's either 180 over pi or pi over 180. Mr. M, which is it? Oh, then there's two of you. How about JM? What do you think? All right. Why did you choose that way instead of the other way? How did you know that was the right way? You're right. Because the pi's can cancel. Good. Doink, doink. Now, let's do some reducing. Anybody see a 3 buried in that 180? I could rewrite that 180 so that the 3's will cancel. This 3 down here will cancel something. So the 180, I'm going to rewrite it as 3 times what? 60. Good. And then you go 3 cancels 3. Cool. Nothing left in the bottom. Just finish it. What's the answer? 5 times 60? Can you do that in your head? If you can't, you can have trouble on the test because there is some small multiplications. 5 times 6 is 30. Add a 0. 300. Raise your hand if you had that one right. Awesome. All right, we just changed from degrees to radians or radians to degrees based on multiplying by a big fraction. And then the fraction is a fact. The fact is that 180 goes with pi, just like 12 inches goes with a foot. Yes? All it's doing is changing. So the original problem was 5 pi over 3. And what if you really don't want to use radians, you want to use degrees? We just changed this into degrees. They are the exact same thing as each other. They're just, it's like saying 12 inches or 1 foot. Or like saying 24 inches is like what? Well, it's like 2 feet. You can use them interchangeably. Use them whenever you want to use radians, use the radians. If you want degrees, make a change and use degrees. But they're equal. Okay, next part is a little formula. This formula is going to be used for the next month, every now and then. You need it. You need to memorize it. I told you there's a lot of memorizing in trig. S equals theta R. Everybody write that down. I'm going to call it SOAR sometimes. Do you get how I'm getting that? It's like S and an O and an R, sort of. All right. Now here's the bad part. They did not choose letters that make any sense, in my opinion. Only one of these makes sense, and that's the radians. No, even that's bad, because R is actually a radius, and it looks like it might be R for radians. And so, anyway, these are awful. You need to label them and memorize which ones are which. This one is, yes, we always use that for our angle. But just by the way the formula is written, you can't tell if that angle is supposed to be in degrees or radians. This formula only works with radians. That's another reason you got to get good at radians, because we're going to use this formula a lot. And this formula only works with radians. So this is radians. That's where you're going to put how many radians is in the problem. And this is the radius of the circle involved. Again, that can be confusing. As you can tell, we got an R, and the R in there does not stand for radians. It stands for radius. And the last thing is this S, and that has nothing to do with what it is, which is the arc length. Why couldn't they have said, you know, A equals, what would be better for radius? It could put R for the radians, and the radius could be like half a diameter or something. That'd be a cheating way to do it, but at least it would make sense. All right. So S equals theta R is something you need to memorize, and it's not that hard once you, it's just like, you know, area equals length times width. It's a simple little formula. So all I got to do is tell you the radians and tell you the radius, and you can figure the arc length. So let's say the radius of this puppy is an 8-inch radius on this circle. And let's say that I want to go 1 radian. The angle right here is going to be 1 radian. Does anybody remember from the definition of a radian how far my arc length would have to be? If this is an 8 and this is an 8, yeah, very good. It would be defined to be 8. But let's just see why this actual formula actually works then. The arc length is supposed to be, well, I know from the picture, it's an 8, equals the radians. How many radians did I say it was going to be? 1 radian. And what was the radius? See how it worked? The formula worked for that. We knew that it was supposed to be a radius. It was like the definition of a radian is that this, and this all come out the same. All right, but of course they usually don't. Usually it's like this. And this is 8 and 8, but this isn't a radian anymore. Let's say it's pi over 3 radians. Figure out how long the arc would have to be. Remember, pi over 3, if you quick at this, you can do a conversion in your head and go, oh, pi over 3, is that like 30 degrees or 60 degrees? Can anybody do that? It's like 60-degree angle. Okay, and it kind of looks like a 60-degree angle, doesn't it? A little bit. All right, so use the formula. S equals theta r. And do I know S? No. S is the arc length. I don't know it. They didn't tell me. So I'm going to say S. Do I know my theta? Yes, my theta is this. That's the theta. Pi over 3. Do I know the radius? Yep, so it's pi over 3 times 8. So what's the answer? Pi over 3 times 8. And I'm going to put that over 1. A shocking number of people think if I times by 8 that I should times the top and the bottom by 8. But you don't. You only times the top by 8. All right, so final answer for this is 8 pi over 3. And you might be like, how is that a length? How is that an arc length? Well, don't forget that pi is just a number. Pi is 3.14. So it's basically 8 times 3.14 divided by 3, which is going to be about 8. A little bit more than 8, like 8.2. Okay? All right. So I'll give you another one, and you'll be able to gauge whether or not you really understood what I was just saying there. See if you're picking up what I'm laying down. This is 4. This is, let me think now, 5 pi over 4. How long? That was how big this is. I should really put it in there. 5 pi over 4 is how big this angle is. And then the question is, how long is the arc then that would go with that? And the arc is running basically around the outside, right here. How long is the green line? The radius is 4. Good question. The other one wouldn't be, the central angle wouldn't be 5 pi over 4. This would be less than 5 pi over 4, right? Because that's 5 pi over 4 is more than a pi, and this is definitely less than pi. Pi, to get to pi, you'd have to go all the way up to here. So it wouldn't work if you tried to do it the other way. All right, so final answer, S equals theta r. And of course, either they're going to give you 2 of the 3 numbers, and you have to solve for the other one. What did I give you this time? I gave you the radius was 4. I gave you the theta was 5 pi over 4. And that worked out really nice, I hope. You get the 4's to cancel, and what's the answer? 5 pi. So how long is that arc? It's 5 pi long. If I asked you in inches, you go 5 times what's pi? 3.14, so it's about 15, 16, something like that inches if you had a calculator, but you won't on the test, so leave it as 5 pi. If I said 20 pi over 4 as a, I get what you're saying. 20 pi over 4 is the same thing, but we do require on all our tests that you leave your answer reduced all the way. So I would just hope that that wasn't one of those R2, R3 kind of questions, because I'd have to mark it wrong if it's not reduced. Okay, I'm going to do one more. I've always given you these 2. I'm just going to, of course, do it the other way, where I give you the arc length, and you have to figure out the radius. So here's an arc length. Let's say I say that that is 7 inches long. And let's say it's a 90-degree angle. Remember, you got to change it in radians or this won't work. This formula only works for radians. Figure out how long the radius is. I gave you this angle is 90. So you have to change that in your head or on paper to radians, or that way you can use the formula SOAR. How many of you had memorized that 90 degrees is pi over 2? Awesome. Many of you had that nailed, and you should have that memorized. So this is, oopsie, this is 90 degrees, otherwise known as pi over 2 radians. So S equals theta r. I know my S is 7. I know my theta, my angle, was pi over 2. because that's the better than 90 degrees, because this formula only works for radians, times r. How do I get the r alone then? This is just a basic equation. Don't forget pi is just the 3.14. So I'm going to go 7 equals pi over 2 times r. How do I get r alone? First thing I'm doing is clearing the fraction. So how do I get rid of that 2 on the bottom? Times by 2. So I multiply by 2 on both sides. 7 times 2 becomes 14. And if you can't solve that for r now, you need to go find another class for second semester. R equals 14 over pi. The basic algebra stuff's got to be the easy part, because we got plenty of trig to figure out, and this algebra stuff has to be easy. All right, 14 over pi. And if you want to know how long is that radius, well, take 14 and divide by 3.14, and you'd know exactly what decimal number it is. But we'd have you leave it this way on the test because there's no calculation. All right, you've learned everything you need to know. So here comes your worksheet, and we'll do a couple together. I'm going to pause the video for just a second while I'm handing these out. Okay, so anyway, just want to tie back to gravity. And on the gravity on Mars, you'd actually kind of like it there. You'd feel a little bit super strong because it's smaller than this place, and therefore, yeah, there you go. Good. Okay, so let's move it to problem number 1. And this is a little bit obscene, and so we're going to skip a few. Let's just skip a whole column. Let's skip the column that has 3, 7, 11, 15, 19, and 23 in it. Skip that whole column. You can just draw a line right down those or whatever. All right. Number 1, 30 degrees to radians. You do need to get fluent with this, so I still am going to leave a lot of problems on here because you need to get like quick with it. Now, I would actually encourage you to memorize a few, and I'm going to write down a list of the ones I would memorize. I wouldn't memorize everyone on your worksheet, no way. But there's some that are going to come up a lot. You can imagine 30 degrees is going to come up a lot. Anybody know it? Pi over 6, very good. Some people are already partially fluent. I'm making you a list now. This you go off to the side on your, maybe at the top on your worksheet, somewhere where you want to remember this list. Maybe in your notes. 60 degrees, pi over 3, very good. 90 degrees, big one, comes up all the time. Pi over 2. Next one, what do you think I'm going to go with? 180. I don't want to make an unrealistic list that you can never remember, but 180, that's an easy one. What is it? Pi. And then let's just go with one more that you should know, like the back of your hand. The one that's between, it's this spot right there. What's that one? 270. And what's that one? 3 pi over 2. It's more than 1 pi. You got to think of it that way. And then the last one, of course, 360. And that's what? 2 pi. If I were you, I'd memorize those. I'd have those like the back of your hand. I'm going to remind you for the next few days and try to pound them into your head. All right, so number 1, I'm totally okay with you just writing down pi over 60 like you knew what it was. Okay, but number 2, you probably don't know off the top of your head. Now, you could do some calculations and say, oh, it's 4 times number 1, and therefore it must be what? And for some people, that's not going so well. So I'm just going to show you the normal way to do this. 120 degrees, what did I say? Multiply it by a fraction, and it's either pi over 180 or 180 over pi. Which one is it? Pi over 180, because that way the degrees can cancel. And now I should do some canceling. The zeros can cancel. That's a really smart thing to do. Makes it easier. 12 over 18. But what do both of them have in it? They both have a 6 in it. This is 6 times 2. This is 6 times 3. And that way I can cancel the 6's. Final answer, 2 pi over 3.
You did 2/3 pi.
That's the same thing as 2 pi over 3, yes.
Well, you got 2
It's
pi.
okay. I agree. 2/3 pi is the better way to say it, actually. They sound different, but they're the same. It's okay. I want you to keep asking questions. All right. Let's move to number 16. Should be a no-brainer, right? What's 16? 2 pi, done, boom. Let's try something like number 18, pi over 4. That's actually one I should add to my memorized list, but I'm going to calculate it for you. Pi over 4, remember it's either pi over 180 or 180 over pi, and if you ever do it wrong, you'll quickly realize, wait a minute, nothing's canceling. And so you'll realize you must be doing it wrong. So that was pi over 4 getting changed by 180 over pi. That's going to work a lot better. There we go. Now it's 180 over 4, whatever that is. And then you go, okay, what goes into both of them? 2 does. 2 goes in here times 2, and this is 2 times 90. And then the 2's can cancel, and I got 90 over 2, but what's that? 45. Okay? Those should be easy. Now smooth backside. At the top of the backside, which formula do you think I want you to write? S equals theta r. That is correct. And just don't forget, when you get a little further in the worksheet, they're going to try to fool you by throwing some degrees in. Can you use degrees in that formula? No. So you might want to right now just find the degrees in the chart, change them over. What are you changing them over to? Can't use degrees, you got to use radians. So you might want to take that 20 degrees in the chart, change it over by multiplying by pi over 180 or 180 over pi, whichever one works. All right. Number 33 and 34 are about concentric circles, and that confuses people. I'd like you to draw a little picture like this. 33 and 34 are about concentric circles. Do you know what that means? They are circles that are inside each other perfectly, like this. They're not like that. That wouldn't make sense. It would be hard mathematically, but concentric circles are like this. They're one's perfectly inside the other, so that when I do the radius of this guy, I can just kind of keep extending it out, and it can be the radius of the other one. Okay, so that's the picture I'd like you to draw for yourself for number 33 and 34. And then it's giving you R1, that's the small circle, and R2 is the radius of the bigger circle that goes all the way to the outside. Okay, so this is R1 just from here to here, and R2 is like this. R2 is like the blue one. Okay, that's all the advice I got for you on that, and that's all I have for the video for today.